Hello everyone, my name is Elvira Rakova and today I would like to show you how to avoid this kind of installation in the factories. So here we see a very typical example. A factory installed nozzles and the machines for cleaning operation. This was the case of furniture manufacturer. And then they cut off the nozzles that they installed, and after we spoke with the operators, they complained that the blowing force was not enough, the flow was not enough, and those nozzles were not performing as they planned. So what they did, they cut it off. And of course, there are two ways to deal with this kind of stuff. First of all, when we cut the nozzles from the pipes and we create an open tube, it creates a higher pressure drops. And even though the force might be a little bit higher, if we have, for example, low force tubes, there are low force nozzles there. But while we have an open pipe at the end, it causes a high pressure drop. It means the higher energy consumption. And at the end, the system doesn't work. And of course, system didn't work also after they cut it off as they planned. So let's see how together with the easy case we can solve this problem, how we can estimate what is actually required for this kind of process, and how we can optimize. I would like to note here that this is a demand side, and demand side optimization is very important. It doesn't mean that we are changing some components. It means that we are analyzing build-ons on that machines, and we are helping our customers to make it more efficient. So let's open now EasyCAS, and I'll show you how we did the calculation there. So here you see our example. The idea that they had before is to install the nozzles that perform with a blowing force of around 0.4 newtons and consumes about 2.3 cubic meter per hour. We took these nozzles from the catalog that they from the database that they installed. So the system didn't have any problems with the pressure drops, and the cost of such a system would be per year around 1,300 euros with the certain input parameters that you see here. And the flows so should work fine. However, the force from one nozzle of 0.3 newton and the blowing of 2.3 cubic meter per hour was not enough. So they did cut it off and got this solution. So basically just cut it off and then you have an open pipe here. So here is an open pipe and you can see it performs with the higher pressure, a higher blowing force of 1.2 newton, and also higher flow rates of 9 cubic meter per hour. So the operators were quite content with this operation. However, as I mentioned before, it causes high pressure drops. In this case, it caused a high pressure drop in the pipes after before the valve and also after the valve, resulting in a cost of 5,000 euros for this operation. So not quite content with the operation. Probably it's very low, still was low force for them, or probably there were high pressure drops. This is what the operators achieved with that. How we can analyze and how we can optimize in this case? We can see if we can install in the same system without changing anything the nozzles with the higher blowing force. So we can go, for example, in the catalog, and we can check the nozzles here, and using the nozzles that we have already, we can check what are the blowing force with the various pressure levels. So we can just check it also from the catalog. So here we have the nozzle with the around 1 newton, around 0.8 newtons, and also with the pressure drops in the pipe. So again, if we don't change the pipes here, the tubes diameter, we will have the pressure drop that is unnecessary here. So the idea is this again, we start from the required demand side. So we put the nozzles that we need, and then we check what the system will suggest us. For example, in this case, it tells us that we need to change the diameter of the tube because it's too small. It has to be at least 6.2 internal diameter, and to avoid the pressure drop of 0.11 bar. The same also for this one. Here is 0.2 bar, means that we have 0.3 bar of pressure drops just for such a small system. So you also can see how much it's going to cost. It's better than it's more efficient. Of course, it's better than the open tubes. However, we always need to remember about changing the components after that. So we cannot just change one component and hope for the best. We need to check the design also before. And here, for example, in this case, we proposed also to have the air jet. The air jet might be a better sometimes solution. It has a higher force, higher cubic meter per hour. The cost will be bigger here, but the performance is better. So on the other hand, we also can see that we have a high pressure drops. So there is the 1 bar pressure drop here and 1.3 bar. So it's 2.5 bar, 2.5 bar pressure drops. That is, of course, not allowed. So I suggest to change it for the next pipe diameter, so I don't have the one that I want to have, but let's say just to avoid pressure drops. The same thing also for here. So I just take the bigger one or the one that is available, and so double click to align the components. And here it suggests us to reduce the pressure level. So we reduce the pressure level at the application. This is one of the good also ideas to have the lower pressure there. Here you also should check the connectors. So I don't want to go in details into the connectors. And let's see if we can have, for example, the 4 bar for blowing the compressor level. And here you see, so now you have the lower cost as well as the open pipes, but the nozzles are more efficient. The thing, airjet is more efficient. The thing is, of course, we need to check at the full layout if we can reduce the pressure levels for the various applications. But this is the first step to check where can be problem, where can be the pressure drops, and also to convince and show operators on how to use it in more efficient way.